So, Akhlaq, I see you. Okay, Aziza. Okay, Aziza here. I think she sent the question. Okay, so anyway, so Aziza's question actually is going to be answered by Layla. So she will answer that one. So maybe we can just go through this quickly, because you wanted 4.5, and maybe we can just revise the first 5 questions. So it says sketched below is the graph of a to the power of x, and a is greater than 0. R is the y-intercept of h, and the points 2, 9, and q 181, 9h. So what type of graph is this?
Hyperbola.
Exponential.
Hyperbola.
Exponential.
Exponential hyperbola. Well, what type of graph is it?
Exponential.
Exponential.
Exponential. Okay. It's an exponential graph. Okay. Yeah. So I see Aziza's just joined. How are you, Aziza? I think this is your first live session. I think you must set up your audio. Aziza, can you hear me? I think Aziza, are you able to unmute yourself?
Yes.
Aziza? Okay, great. So I saw you sent some questions now, which is great. The first one, one of the other tutors is going to answer that one, okay? And yeah, so Layla just, and the other one I'll do, okay? So this is an exponential graph. So just tell me, what are the things you know about exponential graphs? What do you guys know? What can you tell me?
The exponent is an asymptote.
The say it again. Say it again.
Okay, so it's a to the power of x, so that x is an exponent. Sorry, an asymptote.
Well, what do you mean it's an asymptote? The exponent is an asymptote.
So in 4.1. So what would it be? The asymptote.
So they're asking what is the asymptote? What's the equation of the asymptote? But
yeah,
it's not correct to say that the exponent is the asymptote, because
no, what I mean is when we're finding out the equation, so h of x is equal to a to the power of x.
Yes, that's the equation of the x, but they're asking what's the equation of the asymptote.
Yeah.
Yes, okay. So that's the equation of the graph. So basically, the asymptote of the exponential graph is the x-axis, unless it's shifted up or down.
Yes.
Okay. The asymptote of the exponential graph is this graph shifted up or down? No, right? Because there's no q. Q is naught. Do you see that?
Yeah.
Q is naught. So that means it's not shifted up or down. So the equation of the asymptote would be y equals naught. Right? The equation is y equals naught. Then the coordinates of r. What is r in this?
A point in the graph.
It's the y.
The axis.
The y coordinate.
It's the y-intercept, right? So how do we find the y-intercept?
Make x equal to 0.
And therefore, what is the y-intercept? If you make x equals 0. It's a to the power. Yeah, it's a to the power of naught, which is 1. Do you guys see that?
Yeah.
So it doesn't actually matter what A is, right? We don't know A, but it doesn't matter yet, because whatever you put A to the power of, it's always, if it's to the power of naught, it's going to be 1. Unless A is naught. But they say in this function that A is greater than naught. Okay. So determine the coordinates of R. R is naught, 1. Now it says the value of A. Okay, so A is just a coefficient. So how did we say we can find the coefficients? What have we said in the past? Naima, what did we say? How do we find the coefficient of a graph? What can we do? We have to.
You can just
What's
sub
the-
in a coordinate.
Yes, you can sub in a coordinate, or you use the information they give you, right? So you say, okay, y, it's 9, which is the y value. So it's 9 equals a to the power of 2. Okay, so what is a equal to? Because if you use this equation, what is a equal
Plus
to?
minus
You sub in
3.
plus minus 3, but which one do you take?
3.
Why?
Because they
The
tell
power.
you A is greater than 0.
A is greater than 0. Okay, and you can also see that the graph, actually, no, let's not talk about that. So A is 3. So the equation of the graph is y equals 3 to the power of x, right? Okay, we happy?
Yeah.
Okay, now it says D is a point such that DQ, so DQ is parallel to the y-axis. So that's really important, right? So remember I told you guys that everything in maths is a language, so you have to be able to translate. Okay, and then DP is parallel to the x-axis, and they say calculate the length of DP. So the first thing that you have to realize is they're saying that DP is parallel to the x-axis, right? Okay, do you guys see that? DP is parallel to the x-axis. So what that means is that because it's parallel to the x-axis, you already know the y value of D. What's the y value of D?
9.
9.
It's 9 because it's a horizontal line. In the horizontal line, the y value doesn't change, right? Okay. So in a horizontal line, the y value doesn't change. Okay. But they also tell you that DQ is a vertical line, right?
Yeah.
Do you guys see that? And what do you know about a vertical line?
X is equal to the equation will be no.
Yeah, it's x equals something, but what is that something?
X
You want to
equals
give
0.
not x equals 0. Remember, x equals 0 is the y-axis, right? What is this equation?
Oh, x is equal to the intercept.
It will be B.
Yeah.
It's b, right? Because isn't this x value b?
Yes.
So isn't this x value also b? Because it's a vertical line. Okay, so you guys, just from them telling you this, you can translate that into this. So you already know what the point is. It's B9. Okay, you see, so all you really have to do is find B, right? Do you guys agree?
Yeah.
Because if you find B, you can subtract them. If you find B, you can subtract them and say 2 minus B, and that gives you DP, which is what the question wants. Are we all happy?
Yes.
Okay, I want you guys to interact because I can't see you. So I need you to tell me when okay, so Aziza, obviously Aziza is new, so I really want you guys to interact and tell me if it makes sense. So the nice thing with these sessions is you can stop me at any time and tell me if anything doesn't make sense. So do you agree that all we have to do is work out B? and then say 2 minus b, and that's dp. Okay.
Yeah.
And we could work out b. Why? Because isn't b on this graph?
Yes.
So
we
what
just
can you
substitute
do?
into the equation?
You sub 1 over 81 into the equation and you solve for x. Because in this case, what is x? It's b. Because the corresponding x value in y is 1 over 81 is b. And therefore x equals minus 4. If you change 1 over 81 to 3 to the minus 4, x equals minus 4. And since x equals minus 4, b equals minus 4. Right? X equals minus 4, b equals minus 4. And therefore, this is minus 4, 9. So what's the length of b of dp?
-4. Oh, no. It's it will be 6 because you're going to
6.
minus. Yeah.
Does that make sense?
Yes.
Aziza, does it make sense?
It does.
Okay, Amaro. Amaro.
Yes.
Okay, Uwais, Nafisa, does it make sense?
Yeah.
Yes, it
Okay.
does.
Okay. So now for the difficult question. Okay, so now, now it says determine the values of k for which the equation, now okay, it's not, I want to be very clear now. I made a joke now. Okay, so this question looks difficult, but it's just lots of maths and you're just translating that into English. So that's why every person who studies maths is also studying grammar. You see, just like you study English, you study grammar, right? So now we're doing the grammar of maths. Okay. Okay, so it says, determine the values of k for which the equation h of x plus 2 plus k will have a root that is less than 96. So before we do anything, what is this h of x? What do we mean when we say h of x plus 2? What do
You're
we
adding
mean?
We're shifting the graph
No.
2 units to the left.
Yes. Do you guys all agree with that? We're
Yeah.
shifting the graph 2 units to the left. So this is minus 4, 9. So if I just maybe draw this graph here, it's not a best drawing, but you guys get the idea. Let's ungroup that. I'm taking this graph and I am shifting it to the left. Minus 4, 9. I'm shifting it to the left. I don't want those things to be grouped. Okay, I'm shifting it to the left by 2. Do you guys agree? You see that?
Yes.
So therefore, the graph will cut the y-axis at 0, 9. Do you see that? Because you're shifting it to the left by 2. And this point over here, that was, see, this point was minus 4, 1 over 81, right? It's now going to be minus 6, 1 over 81. Do you guys agree? Because you're shifting it to the left.
Yeah.
Okay. Minus 6, 1 over 81. So that's all that's happening. H of x plus 2. That's all it means. You're shifting the graph to the left. Is everybody happy? We're shifting the graph to the left. But what does plus k mean?
Shifting the graph up or down.
Yes. K represents the vertical shift. So right here you've got, and you can just stop me if I'm not making sense. K is the vertical shift. So I could take this graph and shift it up and down. Up and down, up and down. Do you guys see the up and down? That's K. That's the effect of K. Okay. Right. Now, so does everybody understand what this statement means? I've shifted the graph to the left by 2. I've shifted the graph to the left by 2. Right? I've shifted the graph to the left by 2. And the effect of K is that I can move it up and down. You guys will see that.
Yeah.
Yeah.
Okay. So that's all that statement means. Right? That very complicated statement, that's all it means. Now it says determine the value of K. So K is the vertical shift, right? That this graph will have a root that is less than -6. Okay. Now the root just means in this context the x-intercept. Okay, because it equals naught, right? When we solve for x, we're equaling. When we're making this naught and we're solving the equation, aren't we finding the x-intercept, right? You guys agree?
Yes.
When you make an equation naught, aren't we finding the x-intercept? So that's why when they say roots, they actually mean the x-intercept. So what I want you to notice, and they're asking where is the x-intercept less than -6 when I shift this graph up and down. Look what happens when I move this graph down. Because now you've got -6, 1/81. If I move the graph down like here, there will be a point on the graph which is -6 naught. If I shifted the graph down by 1/81, do you guys all agree with that? If it was -6, 1/81, and I shifted it down,
Yeah.
do you see how it's now, the point's going to be -6 naught? Naima?
Yes, I do.
Okay. If I shift it down further, what happens to the graph? What happens to the x-intercept of the graph?
It becomes a negative.
It was always negative, right? It's not, it's negative
It will
here, right?
become smaller.
Smaller, what do you mean smaller?
The number, like
Away from naught or closer to naught?
Closer to naught.
Closer to naught. You guys see that?
yeah.
Yes, here's the x-intercept. Right? Do you guys see that?
Even when you're moving it down from 1/81, doesn't the -6 also increase?
No. So look, we're looking at the root, right? We're looking at the root. So if I move this down, so we've moved the graph down to 1/81, right? You guys agree? We now have the point -60. Do you guys see that? You've moved the graph down by 1/81. Okay?
Yeah.
And if I move it down further than that, what happens to the x-intercept?
Now it goes closer to 0.
It goes closer to 0. Do you see that? Does everybody see that?
Yes.
Until it eventually becomes
Yes.
positive, right? But what is my question asking me? My question's asking me, I want the root to be less than -6, not greater than -6. So if I move the graph down, that's not what my question wants. My question wants me to be less than -6. Okay? Do you guys see that? If I move it below 1/81, it becomes closer to naught. My question's asking me, when will it be less than -6? So when I've moved it down by when I've moved it down by 1/81, that's when the root is -6. Do you guys see that?
Yeah.
When I move it down by 1/81, that's when the root is -6. But they want less than -6. So what must I do to the graph? Move it up. Do you see that? Look what happens to the x-intercept when I move it up. Do you guys see that?
Yes.
Yeah.
But can I move this up indefinitely? What happens when I move it up like this? Does it touch the x-intercept?
Don't have a root.
There's no root, right? There's no root if I move it above. So that's why you can only move it up until this point, because at this point, that's why they asked you at the beginning, the equation of the asymptote is the x-axis. So as soon as you move the graph above the x-axis, there will no longer be a root. In fact, there was never a root to start off with. Only when you move the graph down is there a root. So therefore, k can't be lower than -1 than 1/81. Because if it was lower than -1/81, then the graph moves closer to naught. Okay. And it also can't be greater than naught, because if it was greater than naught, then the graph moves above the x-axis, which means it no longer has a root. Naima, does it make sense?
Yes. Does.
It's not an easy question.
Yeah, I understand it a lot better now. Thank you.
Okay, everyone else, does it kind of make sense?
Yes.
Okay,
Yes.
yeah, okay. Let's look at the next one. So I think Aziza sent a question. Okay. Sorry. So Aziza, are you guys doing circle geometry now in school?
Yes, we're doing
Aziza?
it in school.
Okay. Have you managed to watch the concept videos on circle geometry?
I have been going through them, but I haven't finished all of them as yet.
Okay. Also, maybe have you seen the Tutonic bank yet?
Can you repeat that, please?
Have you seen the Tutonic bank?
No.
Okay, so the Tutonic bank is basically, so I don't know if you must get these messages where it says it basically tells you all that you can do as a student. You can see number one, you can watch the concept videos. Number two, you can go through the bank. And the nice thing with the bank is that it basically contains all the questions Tutonic has received over the last couple of years, and it's categorized. So you as a student can actually go and see all the circle geometry. There's actually a lot more than this, analytical geometry that Tutonic has received, and you can even practice them. And then next to them is the video. Do you see that, Aziza? Aziza,
Yes,
you with me?
I got that message from Layla earlier today.
Okay, so you can even practice these, and then next to it you have the video to check if you've got it right. Okay, so that's the nice thing. Okay, and the entire syllabus is on the bank, so you can even look at other, if you're practicing finance, calculus, there's lots of calculus, lots of optimization questions. In fact, there's 14 optimization videos on the bank. Okay. So let's start. So it says in the diagram below, PAQ is a common tangent to two touching circles. Okay. CFE is a tangent to the smallest circle and a chord in the largest circle. AC and AE cut the smallest circle at B and D respectively. Okay, so there's a lot of words here. Now, before you look at this, right? Before we look at this, I first try and extract as much information as I can from the statement. So it says PAQ is a tangent. What do you guys know about tangents? What can you guys tell me about the tangent? There must be
The
something.
angle between the tangent and the chord is equal to the interior opposite.
Yes, so what's that called? What's that theorem called?
Tan code.
Yeah, I'm actually going to use it like that. Okay, yeah, tan chord. So if I make this angle CAP, what is that equal to?
F2.
F2 and E. Why? Because there's two circles, right?
Oh, yeah.
Because the one chord is here. You can't see that. The one chord is here, and the other one is here.
Oh,
You guys see
okay.
that? Okay, so when they say common tangent, what they actually mean is there's two basically. And what about the other side? So we can say A4. What is A4 going to be equal to?
3
Angle
F3
C
mm,
and F3.
F3 and what
And
else?
C.
And C and what else? There's one more. Wouldn't it also equal B1? Because of angles in the same segment. So you can see B1 is subtended by AD. F3
so
is
D,
subtended by,
I think.
you guys see that?
no.
And that also means that, no, okay, do you see that we're saying, do you agree A4 equals F3?
Yes.
What is subtending F3? AD, right?
Oh, okay, yeah.
Doesn't B1 also subtended by? Okay,
Doesn't that also mean that D1 will also be
100%.
Oh, okay.
100%. Okay, do you guys all see that? Okay. So do you see, are we really filling all this stuff in before? And this, I find it so fun. Like, it's just, just reading this statement gives you all of this. Okay. Then it says CFE. Where's CFE? Oh, okay. Is also a tangent to the smaller circle. Okay. And a chord in the larger circle. Correct. So therefore, we can also apply tan chord here. So what is F1 equal to?
A2.
It's A2, right? And what is F4 equal to?
A3.
A3, right? But what else is also equal to A2 and A3? It's not obvious, but it's there.
Is it B2? Because angles in the same segment.
Yes. So B2, what is B2 equal to?
This green dot here by A.
The
I don't
yellow.
know.
The yellow,
No,
right?
Oh yes, sorry, the yellow.
Look, the FD
Yes.
subtending there, and FD is subtending there. Aziza,
Okay.
do you see? Do you see that, Aziza? Aziza, does it make sense?
I see that.
Okay. So you guys must just, because I can't see you, so you must just tell me yes, even if it's yes, even if you say it too often, it's fine. So okay, right. So do you see how beautiful this is? We've got so many angles here and so many different colors. And we've got, okay, so now let's look at the questions. Okay, and it says, prove that BD is parallel to CE. Where's BD? Parallel to CE. Can we say that they're parallel? BD and CE?
Yes, we can say that they parallel
Why, Aziza?
because the lines are exactly across each other.
I want a more formal answer. How can you prove that lines are parallel?
On angles. But that
You
in
can
the
show
same
that the
line.
corresponding, you can show that the alternate angles or the corresponding angles are equal. You can show that the alternate angles are equal. Do you guys agree?
Yeah.
And aren't the corresponding angles equal? Can't you see the F here?
C and B1. That's what I just saw also.
Can't you see here you've got an F here? You see that, guys?
Hmm.
Okay. So therefore you've proven that and now that they're parallel, you can also draw other conclusions. So if they're parallel, that means that the alternate angles are also equal, but you don't really. So, oh yes, you can say something. No, you can't. No, you can. No, you don't actually know. Wait, let's just wait, hold on. Okay, so now it says B3 is equal to F1 plus E. So where's B3? Where's B3? Okay, B3 is, what is B3? It's the exterior angle of a cyclic quad, right? Do you guys see that? It's the exterior angle of a cyclic quad. Do you guys see that? Here's the exterior angle. Okay. And it's also just in this triangle, right? Okay. And they're saying that's equal to F1 plus E. So where's F1? F1 plus E, sure. Okay, F1 is here and E is there. So basically asking you to show that the purple equals the green plus the
red. Isn't it
green plus the red, right?
Oh,
The
it's F1.
So do you see how nice it is when you use colors? Because then you just have to find the green and the red. Okay. So how can we do this now? So you've got a green here. You've got a so this is a chord. They don't tell us this is the radius, eh? They don't tell us this is the radius. Okay. Do you guys have any ideas? B3 equals F1 plus E. So the exterior angle is going to be, so we've got that. We've got that already. We've got that already. So we agree that B3 equals D1 plus D2. Do you guys agree with that?
Yeah.
Yes.
And we know that D1 is the red, right? Do you guys agree? D1 is red.
Yeah.
So
And
we
D2
just have
is
to.
also green
Why is
because
D2 green?
A1 is, then you get angles in the same segment.
Yes, right. Let's just to show you guys. Do you guys see that FB is subtending A2, but it also subtends D2. Do you guys see that?
Yep.
Therefore, D2 is green, and therefore B3 equals D2 plus a green, and therefore we've shown that, and since F1 equals F1 equals the green and E equals the red, therefore the statement is true. Therefore B3 is, yeah. Okay, Aziza, does it make more sense now?
Yes, it is.
So do you guys see how like the majority of the time on this question, we spent just drawing out the angles? Do you guys see that? Do you guys see, like we didn't start with this. We started by filling out as much information that we could. And all the information that I filled out came exactly from the concepts. You guys see that? So
Yeah.
therefore, the obvious thing is just to know the concepts, because the concepts are your tools. If you didn't know tan chord theorem, then you couldn't have done this. If you didn't know that the exterior angle of a cyclic quad equals the opposite interior angle, you wouldn't be able to do that. If you didn't know that the angles in the same segment were equal, then you wouldn't be able to apply this. Okay, so that's why I want your circle geometry to become like second nature. Remember, I said I'll give you a quiz on that actually. Wait, like you must, when you wake up in the morning, the derivative equals naught is turning point. Okay, when you wake up in the morning, the angle between the tangent and the chord is equal to the opposite interior angle. Okay.
Yes.
All right. All right.
Yeah.
Okay. And all of you are getting up pretty much the same time, so you can all say it together. And maybe give you the test every morning. You must do that test actually, just to revise. It takes like 30. Like okay, that's the wrong one. That's the wrong one. Sorry. This one. Nafisa, which one do you want? Is there a particular one, or would you like to do all of them?
Can we do all of them, please? 5.2 and 3.
Okay, but but the first one is reduction, right?
Yes.
Yes.
Right. So
Yes.
the reduction. Remember, I said I want you guys to become very confident with that. So what's the diagram?
All stations to Claremont.
And Nafisa, and I mean Naima.
All students take cocaine.
Okay. Okay, and what's the first step?
Quadrants.
Quadrants, right? Which quadrants are we in? Okay, great. Number 2.
The sign.
Number 2.
The
The
19
signs.
and 2
Positive or negative.
Yeah, number 3.
If the thingy stays the same or not.
Yes, because if it's 19 to 70, it changes, and if it's 180 or 360, stays the same. Right. So let's take cos theta minus 180. Who's going to do that one for me? Amara, can you do cos theta minus 180 for me?
Okay, I'm doing it now. So this would be,
So follow the steps, okay?
okay. So it would be cos of negative 180 plus theta.
So you're taking it out as a bracket.
Yeah.
But you don't have to if you just say which quadrant you're in. Okay.
It's a quadrant, but
yeah, so it's going to be, I mean, if you really want to, you can add 360 to it. Because when you add 360 to a cos, then what happens? It doesn't change, right? So then this becomes 180 plus theta if you add 360 to it. Do you guys see that? Nafisa?
Yes.
Okay, so you don't actually have to worry. So which quadrant is this in?
okay, so cos in the fourth quadrant, but 180 plus theta is the third.
Yes.
So it will be negative cos of theta.
And why did you not change it to sine?
Because it's not a
It's 180.
Because it's 180, right? So okay, great. And Naima, can you do cos theta plus 90?
90 plus is in sine's quadrant. It's cos is negative and it changes to sine theta.
So it's going to be positive and then sine theta, because it's negative sine theta, right? Cos 90 plus. But because it's a negative in front already, so it's going to be positive. Okay. Ways, do you want to do tan 180 minus theta for us? Ways, so you,
Second quadrant, it's negative,
yeah,
and I think it stays the same.
yeah. So it's negative tan theta, but it's 2, right? So it's negative 2 tan theta. All right. Okay. Now, Nafisa, do you have any ideas of how you could simplify this?
I have an idea.
Can we change the tan to sine over cos?
Yeah. Do you agree this is just 1 over 2 tan? Or half 1 over 2 tan, right? Do you
Yes.
agree this it's the same thing? And isn't 1 over tan just cos of a sine? Because tan is sine of a cos.
Hmm.
So 1 over tan is cos of a sine. So you can even write this as, you write the cos there, you cos there, and the sine at the bottom. And then the sines cancel. And then you're left with minus half cos squared. Have I skipped too many steps?
Yes.
Okay. So do we agree 1 over tan is cos of a sine theta, right?
Yes.
Yes.
So 1 over 2 tan is just going to be cos of a minus cos of a, or minus cos of a 2 sine. Because this is just 1 over 10. And here you've got minus. Do we agree?
Yes.
Okay, so now we just substitute in. So that we end up multiplying by cos on the top and minus 2 sine theta at the bottom. Doesn't actually matter where you put the minus. And then what happens?
You can cancel the signs.
Right. And so it becomes minus of cos squared theta. Okay.
Yeah.
Then number 5.2.2 says, for which values of theta is it undefined? Okay. So what can make an expression undefined?
If
Dividing
the
it by
denominator is 0.
If the denominator is 0. Does this have a denominator?
Yeah.
What's the denominator?
2.
210 into 180 minus theta. So it's
Yeah,
negative theta.
so that's good.
The
So that's
simplified version.
a very good answer, because do you guys see how even though we simplified it to this was still the original denominator? Do you guys see that? This was the original denominator. So you actually have to look at this also, because even though this doesn't have, like this is never undefined, right? This expression on its own, because can cos be undefined? Guys,
Yes,
can cos be undefined?
I think so.
Maybe. Who's going to answer? Nafisa? Naima?
So what did you ask?
Can cos be undefined?
Hmm, I think so it can.
Okay, now this is why you must learn the cos graphs. Okay, you must memorize the cos graph. So the cos graph does this, right? Is it ever undefined? No.
No.
Only the tan graph is undefined. Okay.
Oh, is it because it has a limit of 180?
No. No. Okay, so you guys must watch the concept videos, grade 10 concept videos on the trig graphs, but only tan can be undefined. However, if you put a function in the denominator like sine or cos, right? The denominator being naught is also undefined, right? So therefore, if you can show that sine is naught or cos is naught, then that will be undefined. Do you guys see that?
Yeah.
But no function, but sine on its own will never be undefined. Only if it's in the denominator. Do you see that?
Yeah.
Only if it's in the denominator. Okay, so guys, I want you guys to go watch on the section mind map, because you have a week off now, Lisa. Okay, so I want you to watch the section mind map, Amaro, the concept videos on the trig functions. Okay. In fact, everything, to be honest, but we'll start with the trig functions. Those concept videos, especially grade 10 concept videos, because a lot of those things are building blocks for what you guys are doing in matric now. So basically, in the denominator for this expression, you've got minus 2 tan of theta, right? Okay. Now, when it comes to the tan function, tan is undefined at 90. It's undefined at 90 plus 180k. That's something you will come to learn. You probably have learned this already, right? But do you agree that tan's in the denominator?
Yeah.
So therefore, it's not just what makes tan undefined, it's also what makes tan naught. Do you agree?
Yeah.
It's only one person. Amaro, Nafisa? Amaro? Nafisa?
Yeah.
Then you-
Okay, so what makes tan naught? Tan is naught when theta is naught and 180. Okay, so therefore your final answer will be naught, 90, and 180. 3 marks. Usually the marks gives it away, right? So if they give you 3 marks and they want 3 answers. Okay. Nafisa, does it make sense?
Yes, it does. Thank you.
Okay. So guys, I want you to watch those concept videos for grade 10, okay? The section on the section mind map, the trig concept videos. Okay. Prove that sine 2 theta over theta, sine theta, is 4 cos theta minus cos 2 theta plus 1 over cos theta. Okay. So always try and expand and see which side you want to work with. So what's the identity for sine 2 theta?
2 sine theta cos of theta. Oh, it's not an identity sign. It's a double angle.
So it's a double angle identity. Remember, the identity is a, it's double angle falls within the category of. So you have compound angle identity, double angle identity, sine over cos equals tan identity, square identity. Identity just means that it's a proof. It's something that you've proved to be true. You can identify that by, okay. So, and that's over sine theta, right?
Yeah.
So therefore we can cancel. So it just becomes 2 cos theta. So we have to show that the right-hand side is 2 cos theta, in other words. Because we can't simplify 2 sine theta much more, right? 2 cos theta. We can't simplify it much. So what can we do? Maybe make the denominators the same? What do you guys think? Naima, do you think maybe making the denominators the same would help? Hello? Naima.
No.
Or what do you want to do? What do you think you should do? We should do?
I think you find an LCD for this question.
Yeah, so the denominator. Find a common
Okay,
denominator.
sorry.
That's LCD. Yeah,
sorry,
it's the
sorry.
same. So what's the LCD?
Cos theta.
Cos theta, right? So therefore it becomes, what's the numerator going to become?
That will stay for cos theta. No, it will become 4 cos squared theta.
Right, great. Okay, so it's 4 cos squared. And it's going to be minus cos
The other
2.
one will stay the same.
Other
Yeah.
one stays the same. But we must just be very careful here, because this is in brackets, right? This is brackets. So therefore this is minus that. So it's not, so it's actually minus 1. We must be careful with that. So which identity, what can we do from here? Amaro, did you have any ideas what we could do from here?
Isn't it cos? Oh no.
I think maybe we can trinomial it. I'm not sure though.
So let me teach you something that I used to do. So if you see, this is what you want, right? You want this. So you have to say, okay, well, how can I manipulate this so that I can give me this? So I want, my answer is cos, right? So I want to keep it with cos, keep the cos, right? Do you guys agree? Keep the cos.
Yes.
So what if we apply the cos 2 theta identity, but just use the cos one?
So 2 cos squared plus 1. I think that's
Do you guys see that, Nafisa?
No.
Nafisa, do you see?
No,
Cos 2 theta.
we're gonna expand that double angle.
Yeah, because your answer is theta, so it doesn't have 2 theta. So always try and think, if you see a double angle, can I expand it? But remember, the cos 2 theta has 3 identities, right? There's 3 possibilities. But I'm going to choose this one. Why? Well, firstly, it will cancel the 1, but also because my answer is cos. So I don't want to have sine. It makes more sense to keep it with the cos. Keep it cos. So what's cos 2 theta minus 1? It's just going to be
2 cos square.
2 cos squared theta,
Yeah.
right?
Yeah.
Because it's 2 cos squared theta minus 1 plus 1. Do you see that? And then look what happens.
Common factor. Oh no.
What's next?
You can simplify the top and then we can cancel it with the bottom. I think.
Right. You see, so what's the top going to be?
2 cos square theta.
Do you see that? Amara, do you see that?
Yes.
Okay, and over cos theta, so what's the final answer going to be?
Just 2 cos theta.
So do you see how we approached this question? Nafisa, I know you asked the question, but do you see how we approach this question?
Yes.
So when you tried it, what part was a bit tough?
The whole question. It was first because I didn't know which side to simplify. The 2 cos theta, I didn't get that part at the beginning.
So the nice thing with the sine, always start with sine, right? Because sine 2 theta is always going to be one thing. Do you guys agree? Sine 2 theta is always going to be one thing. It only has one answer, whereas cos has 2 answers. So I always try and leave this for last, because imagine if you started with this, you don't know which one to choose. So I start with the sine first, because I know what sine 2 theta is. Okay, right?
Yes.
Nafisa?
Yes.
So that helped me a lot. That helped me a lot. So then that meant that I know that I'm only looking for cos. So now I know, because I'm only looking for cos, this cos 2 theta must stay cos. Okay. So I want you guys to, what I want you to take away from this is that with identities, there's no one method. I hope you've come to realize that. There's no like one method that solves everything. What you have is concepts, and you just have to apply those concepts in different ways, different configurations, and until you see what works. But as you start practicing lots and lots of examples, you will start realizing which configurations work best in some situations and which configurations work in other situations. And that's how you start becoming better. So what you have to do, number one, is that you have to firstly understand the concepts. So you have to memorize the identities, memorize, the identities. And then after you've memorized the identities, practice lots of examples. And then as you practice examples, you will come to realize that, hey, okay, I need cos, I need to maybe use the cos identity. So I only have cos. Okay. Does that make sense?
Yeah.
Yes.
Okay. So are there any other questions? That was the last one. It was on the group.
Yeah, I'm sending one now. Just hold on.
Okay.
Sorry, Elias.
Mm-hmm.
I have to go very quickly. So I have to go.
Okay, that's fine. You can always. So the nice thing with this, the timestamps is that you can go back
Watch it.
to like specific questions.
Yeah.
Yeah.
Okay. Thank you for today.
No problem. See you. Okay. 4.2, the graph of an increasing exponential function.
Can you hear him?
Can you guys hear me?
Yeah, now I can.
Can you guys hear me?
can. Yeah, now, yes.
Okay, yeah, that was just, I think, the iPad for some reason. But you guys can hear me now, right?
Yes.
Okay. So
Can you hear
let's.
him?
Can you guys hear me?
Yeah, now I can.
Can you guys hear me?
Can. Yeah, now, yes.
Okay, yeah, that was just, I think, the iPad for some reason. But you guys, YouTube is, yeah. So you can hear me now, right?
Yes.
Can you hear me now, right? You guys can hear me?
Yes, we can.
Okay. So let's say increasing exponential function. So again, there's a concept video on exponential functions that I really want you guys to watch. It's on the section mind map. Basically, there are 4 types of exponential functions. There are 4 types. There's the one which goes like that. There's the one which goes like that. There's the one which goes like that. And there's the one which goes like that. Do you guys see that?
Yeah.
Okay.
I don't know if it's just my phone, but it's paused. I don't know.
Yeah, Sam, I didn't see anything you did on the screen now.
Oh, okay. Wait.
Yeah, it's just saying
Okay.
pasting from Ilya's phone stopped in there.
Sorry. Let's try and remove. Just see what happens. Just hold on. Just hold on, guys. You guys can still hear me, right?
Yes, we can.
Yes.
Okay. Okay. This is some. I'm just going to end and restart the meeting. Okay. I'm going to restart the meeting, okay?
Okay.
Okay. It's the same link as